Now let us analyze a fixed wedge on which a block of mass m has been kept. Gravity will act in the downward direction as shown. So the force of gravity will have two components. One component will be down the plane. So I am resolving the force of gravity. One component will be down the plane and one component will be perpendicular to the plane. The down the plane component of gravity can be written as, so this is the down the plane component of gravity. It can be written as mg sine theta, because this angle happens to be theta from fundamental trigonometry and similarity of triangles, and this component happens to be mg cos theta. So the force that is opposing mg cos theta is the normal reaction force that the wedge will supply, and there is no force opposing mg sin theta. There is no friction present and the wedge is a fixed wedge. So if we choose our x direction to be down the plane, this is our x direction, and our positive y direction is perpendicular to the plane. If we happen to choose the two directions like this, so this is x and this happens to be the y direction, we can write down the x direction equation as mg sin theta is equal to m acceleration in the x direction. Therefore, acceleration in the x direction happens to be equal to g sin theta. And in the y direction, we can write down n minus mg cos theta is equal to m into acceleration in the y direction, which happens to be 0. Therefore, n is going to be equal to mg cos theta in the y direction, and the acceleration in the y direction is going to be 0. So this is the analysis of the wedge. It is very important to learn to resolve the components of the force mg down the plane as well as perpendicular to the plane. Sometimes instead of the bottom angle being given, sometimes this angle is given as alpha. In that case, this component will become mg sin alpha and this component will become mg cos alpha, because alpha happens to be 90 minus theta. So according to the angles given, it is important to resolve the components appropriately. Also, sometimes the resolution of the normal reaction along the horizontal and vertical direction is required. For us to be able to perform that, we need to understand that this particular angle also happens to be theta, and at the same time this particular angle also happens to be theta, and the vertically opposite angle, this also happens to be theta. So this is the entire theta-ness of the diagram, if we can invent the word and utter it out. So all the angles that are theta have to be understood. So if we are going to choose this direction as the horizontal direction, let us say the x dash axis, and this as the y dash axis, so sometimes we may need to resolve the normal reaction along the x dash axis. So the component of normal reaction along the x dash axis is going to be equal to n sin theta, because of the theta-ness of the situation, whatever theta-ness we have mentioned and diagrammatically, and this particular vertical component is going to be equal to n cos theta. Alright,